All right, welcome everyone to our live stream geometry session. So we're recording this. So I'm going to first start with a problem that was sent to me by I3435, so one of the viewers on my channel. So let me share my screen. Hold on just a second. All right. So I have not solved this problem yet. One sec, let me maximize the screen. Can you guys all see the problem?
Yes.
All right, so I think this is from, I don't know, I think it might have been like a Romania team selection test, but I have not looked at it yet. So let's try to see what we can do with it. So ABC is a non-isosceles triangle. And then we draw the end circle. So yeah, I haven't found a faster way in GeoGebra to do these kind of things, but if any of you know, feel free to let me know. So I'm just going to draw a couple things and then I'll hide them later. All right, so we have X, Y, and Z. All right. And O is the circumcenter. Whoops. All right. And then OI, whoops, meets BC at D, which is interesting. I like these problems where you join O and I. I feel like often they're like really insightful problems. And the perpendicular from X to YZ intersects AD at E. That's interesting. Let's see what that looks like. It was E already. It's pretty nice. And we want to show that YZ is the perpendicular bisector of EX. All right, let me just move things around. So E, looks like E usually lies outside the triangle. Yes. All right, so how do we show YZ is the perpendicular bisector of EX? This looks tricky. You got like the in-center and the orthocenter, I'm sorry, the in-center and the circumcenter combined like this. So I'm going to just draw on this point. I feel like sometimes it helps. It's a good way to start here. So yeah, most of these problems I would say are a little bit harder than the ones from my last session. But I have some easy ones just in case we get too stuck. All right.
For me, I think the intuition might be getting angle YEX and angle YXT equal, because if we are able to prove them equal and somehow even if G is midpoint or either YG is perpendicular, then we are able to prove that it's the perpendicular bisector.
So you're saying like angle YEX equals angle YXE?
Yeah. And
yeah, because we can calculate angle YXE pretty easily, right? Because that would be 90 minus angle ZYX, and that we should be able to get. So yeah, angle YXE, yeah, the question is how we would get that. So IO is like the line between the center of two circles. So that's perpendicular to the radical axis, but I don't know how useful that is.
No, it is quite useful. So there is a property called Euler's line in Euclidean geometry. So like, uh, let me check out.
But that's not I and O. I think that's OH and the 9-point
Yeah,
center,
yeah.
and maybe the centroid.
It's completely unrelated. Yeah.
But I'm kind of curious. Let me play around with this diagram a little bit. So this would be a lot harder to do in a competition, obviously, because I wouldn't have GeoGebra, but we're not in a competition. So let's see. So, I mean, this line through A and I is parallel to XG, and OH passes through the midpoint of BC. Okay. This actually looks a lot like, you know, problem 1 that I did on my channel. So it's like I think it's like, no, I think that problem you take a perpendicular from the midpoint to YZ, and then you show. I'm just curious. I'm going to try something just for the fun of it. So I'm going to let this point be the perpendicular. I don't know if this is really going to go anywhere. I might delete it if it doesn't. But let's see. So basically, from the first problem on my YouTube channel, L, K, and I are collinear. Let's see if this does anything. Okay. Yeah, I'm not sure that'll help us. Yeah, I'm going to erase all that. Okay. Let's see, maybe we could use projective geometry. So we want to show that G is the midpoint of EX. So is there anything, could we project through point D? Let's see, like, I mean, it's the same as showing, like, if we label this point K, it's the same as showing that EK is equal to, or actually, maybe not. But yeah, so what if I drop a perpendicular from X to this? No, I'm sorry. I want the perpendicular through X to this. I'm going to erase that. So I'm trying to think, maybe I could use power of a point. Like, so we have GX times GF, and then we could use power of a point. EF times EX. I'm not sure if that does much. Sorry, I'll be right back. I have to use the restroom. All right, let's see.
I think that AH might, if we prove that AH parallel to FX or EX.
Oh, AH is parallel to EX because AI, basically EX is perpendicular to YZ from the problem statement, and AI is also perpendicular to YZ by symmetry. So they are parallel.
So after then, I think we should join FY.
Join FY.
Yes.
Okay.
And then, sorry, not FY. It's no, sorry, I messed up.
This is a really fascinating problem. Like you're joining the in-center to the orthocenter like this, and you're seeing where it hits BC. Yeah, I'd really like to use projective geometry somehow. Like,
The problem I find this is point D. I'm not able to define point D. Like most my trick in mainly 10 or 20% of the difficult questions I attempt, I always try to define that point. For example, I and O are defined, and in this problem particularly, and any other difficult type of problem. Um, so point D is it could be any anonymous point, but it is not. It is the intersection of IO and BC. So it
yeah,
has to has uh, something something in common and something of vital importance. And if we are able to define D, then AD makes sense because we are getting much acquainted Sevian because it's not a normal Sevian. If you are able to establish some relation, might be with trigonometry we could try.
yeah. I have an idea with projective geometry. So basically, we want to show that G is the midpoint of EX. So what if we project through D? If we project EGX and the point at infinity, because basically we want to show that the cross ratio EXG infinity is -1. Basically, we want to show those points are in harmonic conjugation, right? So if we project those 4 points through D onto the angle bisector AI, then we would get A, L, and then this other point, which I have to draw. And
Sorry,
then
how did you describe conjugation? Harmonic conjugation?
they're in harmonic conjugates if the cross ratio is 1, right?
Uh-huh.
So
Oh, got it.
yeah, so basically we want to show EXG in the point at infinity. We want to show that that cross ratio is 1 or -1. Some people, like on my channel, I don't always mention the sign, but technically it's -1. So we want to show EXG and the point at infinity is -1. If we project through D onto AI, that cross ratio is the same as AM L infinity. So, actually, that's trivial. That's just because, yeah, we don't need projected geometry for that. So I'm gonna relabel this point N. But basically, I guess what I'm saying is showing that EG equals GX is the same as showing that AL is equal to LN. So we want to show L as the midpoint of the angle bisector. I'm not sure if that's helpful or not, but just something I thought of. I mean, so saying, let's see. So saying that L is on the midpoint of the angle bisector, it's kind of the same as saying that, like, if we take these two, oops, if we take these two midpoints, then L lies on MP. Not sure if that helps at all.
But G is the midpoint of ZY.
G is the midpoint of what?
Sorry, can you define that point of intersection of A, AN and XY?
AN and XY.
It bisects MY, sorry, ZY.
AN bisects ZY, or I'm sorry.
ZY, yes.
Oh yeah, AN bisects ZY. Yeah, so there's like a point right here. So isn't there some kind of a theorem, like, about if you take like the intersection of an angle bisector with a midline? Like, I think in EGMO, there's some kind of like, what is it? Yeah, so let me look it up for just. I think it's if we let ZX intersect MP at a point, then I think there's a chapter in EGMO that says CI and R are collinear. I think, whoops, I think that's what it is. So yeah, the diagram's starting to get a little complicated, but let's see. Okay, so basically I wanted to show that L lies, so L is the intersection of GB with AN. Let me delete it for just a sec. Yeah, I'm gonna undo a couple things. Yeah, I don't know if this is really going anywhere. Let's see.
How about we prove EZ and ZX equal?
EZ and ZX. We could try that. Let's see.
Yes, I was trying from that time only how to prove EZ equals CX, or we prove angle EZG equals angle XZG.
Yeah, it definitely looks simpler.
Let's see. How do we? So yeah, I'm trying to think how we would get EZ.
It's not EC, it's EZ.
EZ, right?
Yeah, yeah.
Yes.
Yeah.
Well, we can try from angle ZXB. So angle ZXB might be equal to what? Uh, I'm talking about ZXB. It has to be equal to either C or A, right? So what would it be?
ZXB.
ZXB and ZXB would be equal to
That's
uh,
not 90 minus B over
ZYX.
ZYX. Yeah, that equals ZYX. Yeah.
So ZYX. Um, yeah. So I'm thinking, is ZXB equal to either of A or C, or is it completely something different?
Angle ZXB.
Yeah.
That's 90 minus B over 2.
Yeah. See, 90 minus B over 2. So okay.
Yeah. What if we try to form like a? I'm thinking about a whole bunch of things. What if I try drawing the circumcircle of EZY? No, that doesn't do much. Uh, I kind of like um, I kind of like showing that AL equals LM. But yeah, I'm trying to think how to do that. Is there another point we can project through? What if we take, so we have the points A, L, and M. We want to, what if we project through point G onto AB? Or even BC? Yeah, what if we, I'm going to draw AX. I'm sorry, I'm going to draw AG. That almost looks perpendicular, but it's not to BC. Or at least, is AG perpendicular to BC? There's no way that could, is that really true? AG is perpendicular to BC, it looks like. No, it's not. It's just really close. I feel like I've done a question like this before. So basically, this is looking eerily familiar. So, okay, so we want to show that AL equals LM. And so we're going to project through point D on, no, I'm sorry, we're going to, what was I doing? We're going to project through point G onto the line BC. Okay, so Yeah, no, that looks like it really gets somewhere. So we want to show that the cross ratio, let's see, we want to show that NM XD is in harmonic conjugation. We want to show that these 4 points, NM, X, and D, are in harmonic conjugation. All right. I like
So you
that.
projected G on BC, right?
Yeah, I projected through G onto BC. So I'm actually, so, yeah, I'm sorry. I'm gonna, just a sec. So let me see if I can do something for a sec. Do you guys still see the geometry problem, or do you see my Word document?
No, it's
You see my
the
Word
upper
document?
file is visible, but the clear problem is not visible. If you could scroll down, or
Okay. Hold on just a sec. All right, I'm trying to maximize. Okay. So
yeah, it's good now.
I'm just going to write this down on paper and then type it in really quickly. So we have A, M, L, infinity is equal to N, M, D, X. Okay. All right. So I3435 says the triangle center ABCN lets you draw the Kimmerling center. That's really useful. I did not know that. So, okay, in circle. I probably should have known that, but yeah, thanks I3435. Okay, so we want to show this cross ratio NMBX is equal to -1. And you see how I did this? Because basically we know that AM is parallel to EX from what I said before. And so if you project G through the point at infinity on line AM, that's the parallel from G to AM, which is EX. Okay. So we have these 4 points. What can we project them through to show that the cross ratio is -1? What if we project through A? I'm thinking.
I think if we prove that F is the orthocenter of triangle EZY, then it will also prove.
Let's see if that's true. That could work. Is that a right angle? Might be. It says 90, but it doesn't show the right angle thing. Oh, it is a right angle. Okay. So how did you get that? Let's see.
If we join YF and extend it to EZ, then angle ZYF.
Okay.
Angle ZYF should be equal to angle ZXF.
ZYF equals ZXF.
Yes.
Oh, I see what you're saying. Yeah. Okay, so we want to show F as the orthocenter. Let me try that. So the reflection of the orthocenter over a side lies on the circumcircle. So basically, if we take the orthocenter of triangle XYZ, then if we could show that it's the symmetric of F over G, that would solve the problem, right?
Yes.
Okay. So then we could get, hold on a second. Something seems weird here. So can we delete everything for, why do we even need I in it? Why do we even need O then?
Yes. We have to do something with O and I, otherwise how can the problem go?
Hold on. Oh, no, it's not enough just to show. So whatever the orthocenter of XYZ is, we know the reflection of it lies on the circumcircle. So we know that F, we know that F is the reflection, but that's not enough. Yeah, that's not enough to show. Yeah, let me think about this. So I was thinking, sorry, I'm going back to this, but what if we take N, M, D, and X and we project through A onto YZ? Is that a good strategy? Or what if we project onto this line IOD? I mean, that feels like it makes a lot of sense. So, like if we take that intersection point, so if we project N, M, that's a little ugly. I was going to project it on the line IO, but it didn't work out totally like I thought. But M goes to the midpoint of XY, right?
Yes.
Yeah, it's just this segment AX. Yeah, I want to show that GQPK is that cross ratio is one. And then I could like try to project through D, maybe? No, maybe. Yeah, once we get, I'm not sure where to go from GQPK. I see someone in the chat. Oh yeah, okay. Let's take a hint from I3435. So yeah, you can either talk or type it in the chat, either way. All right. The projection you have is the first part, and then project through I. Okay, so NMDX, can we project that through point I? Yeah, that sounds good. Okay, and then we project onto line OJ. Ah, man. Okay, so let me try that. I'm going to take those 4 points and project through I onto line OJ. Does IN intersect this arc at its midpoint? Yeah. Let's see why that's true, but that's really interesting. I feel like that gets us really close then. So let's just assume that that's true. Of course, I got lucky because I'm using GeoGebra. But let's just, for now, assume that Ni meets the circle at its the midpoint of arc BAC. And then if we do the projection, I'm going to write this out on my paper. Hold on just a sec. R that basically solves it. Okay, so if we know that I, R, and N are collinear, then projecting through I would solve the problem. So I'm going to write it out. All right. Wait, did I do that right? NMDX. Oh, whoops, what am I doing? I'm sorry. Oh, I was just looking at my paper and I copied the thing above. So it would be RHOX, and that is easy to see that is equal to 1. So I'll explain that. But if we know R, I think it was R, I, and N are collinear. So we have to prove that. Sorry for blocking the diagram. Yeah, okay. So if we take NMVX, we project through I, so and onto the line OJ. So N would go to R if we knew this fact, and then M would go to H, and then D goes to O by the definition of the problem, and X just stays at X, or hold on a sec, no, X goes to the point of infinity, I'm sorry. And we know that this cross ratio is 1 because O is the midpoint of RH, because O is the center of the circle. So since O is the midpoint of RH, this cross ratio has to equal 1. So how do we show RI and N are collinear? I feel like I've done this. This looks so familiar. Is this, so, how do we show that? So, like I said at the very beginning, maybe I can use the thing that was problem 1 on my channel. So let me see. Yeah, I might just be able to use problem 1 from my YouTube channel. Let's see. So yeah, I'm gonna well, I think if I delete this, stuff might go away, right? Oh no, okay. Yeah, I feel like this shouldn't be that hard to show that those are collinear, but I'm not sure. So I think we could do an angle chase to compute angle IRH, right? That doesn't seem too hard, but NRH, uh, let's see. Maybe we could use some projection to show they're collinear.
Did you get some extra properties for point n?
Point N?
Yes.
Yeah, that's the key. I'm not sure. I wonder if somehow we can use projections to show that Ri and N are collinear. Yeah, I don't know of a way right now.
So if we could rotate the figure, we could see NIR or are collinear or not.
Well, actually, I just thought of one way to do it. So, I mean, Ix is parallel to Rj, right? So if we can show that Ix over Xn is equal to Rj over Jn, that would work. I'm not sure how good that is, but actually, I don't know if I like that. I kind of like what I was saying before about like using problem 1 for my channel. So it says like, so basically, if we take a perpendicular from J to YZ, it makes it look like it passes through Y, but it doesn't necessarily. Yeah. If we can instead, using problem 1 on my YouTube channel, we can show that Si and N are collinear. I'm not sure if that's any better. Yeah, I don't know if that's really any better, showing Si and N. Maybe. Mhm. Is I the midpoint of Sn? No, that doesn't make sense. Yeah, we have to use something about the definition of point N. Like, how do we get our hands around N? Um, yeah, I don't know. For some weird reason, I feel like extending AN to meet the circle. Uh, hmm.
I means we should check around line AGs, means because line EX is parallel to AM. So doing angle chase between there, we can get something and define it.
Say that one more time.
EX is parallel to AM.
EX is parallel to AM. Yes, that's true.
And if we do some angle chasing here, AG, because AG extended meets BC at point n. So if we try to do with some angles of AG, we can also try to prove that n.
So we could maybe show angle ANI is equal to angle ANR or something. Not sure.
No, I'm not sure.
Or ARI equals ARN.
But out of all possibility, the distinctive part we've got here is F is the orthocenter of that EAY. So if I think we could use that for some reason or prove that, then because if F is the orthocenter, then half of the thing is already proved because G is 90 degrees since
Well,
uh,
you're
EF
saying if
extends to G and 90 degrees.
you're saying if F is the orthocenter of EZY,
No, F is the orthocenter of EAY.
EAY.
Yeah.
No, EZY.
But yeah, no, if F is the orthocenter of EZY, I agree that solves the problem.
Okay, okay, yeah.
Um, But yeah, I mean, if we're trying to do it with the hint, I feel like showing R, I, and N are collinear. I feel like it's trivial somehow. I feel like I'm missing something. I feel like we're missing something obvious here. But I'm not sure. So I don't know. Maybe we could like, because I is like I lies on that circle. So maybe we could show. No. I'm gonna erase that for just a second. Like I feel like there's got to be some ratios. So like IX, yeah. So I mentioned that. Yeah. Let me see what the. Maybe I could do some kind of projection. No, I don't think that's. Okay, so I'm starting to see. It's a good way. Yeah, what do we do with point N? I feel like somehow we got to. You have to do something with it. I'm just gonna try stuff. Um, no, that doesn't really do anything. Does IA equal IN? That would be interesting. No. Okay, so I mean, it's kind of like Now the thing is, AN is not perpendicular to BC. Otherwise, we could show like AN over AI is equal to IH over HR. Yeah, I'm trying to use similar triangles somehow. So let's say for a moment that they are. Yeah, what is that saying? So is angle NID 90 degrees? That kind of looks like it might be true. Let's see. No. All right, let's see. Yeah, let's take another hint. RX and AN meet on ABC. Is this from, let's see. Let's think about why that's true. So you gave the length to it. So we have consider the spiral similarity between YZ and BC. Yeah, I was thinking about that. So yeah, we have a spiral. Yeah, it takes. Okay, so
I'm sorry, could you explain spiral symmetry?
yeah, so basically that's just a fancy way. Actually, we don't even really need spiral similarity. It's just a fancy way of saying, at least in this case, that AZIY, that quadrilateral, is similar to RBHC. And so basically, that, hold on just a sec. Okay, so spiral similarity, it really just says AZIY is similar to RBHC. And so, like he said, if we draw the line AN, and we let it meet the circle at S, we want to show that R what was it? Did he say RX? I forget. We want to show that RX also passes through S. Yeah, so basically we want to show point G corresponds to I'm just sort of thinking this through. Hold on a second. Okay. So I've seen this idea before. So I remember, I think I might have even done a post with something like this. So this might kind of come out of nowhere, but I've seen this before. So I'm going to prove that ZG over GY is BN over NC. Okay. So that's true because by an angle chase, triangles ZGB and GYC are similar. I've seen this before. I'm trying to think how to prove it exactly. Wait, is it true? I think it's true. Yeah, okay. So this is kind of I have an argument in mind. It's a little complicated. But basically so we can show that a triangle ZGB is similar to YGC. So we know that ZG AZ, I think it's AZY. Hold on. Okay, so that's step one. So you can see that, right? So angle BZG is equal to CYG because they're both 180 minus the angles in triangle AYZ, and those two angles are equal. Does this step make sense? I'm sorry, can you guys hear me?
Yes, it does look similar, but I cannot find any intuitiveness in
Intuitive
other
reason why it's
than
true.
looking.
Yeah, I'd seen this before. So this only shows that one of the pairs of angles is equal, right? And then there's another thing we
Uh-huh.
can do to show that the other pair is equal. So um, this kind of comes out of nowhere, but basically,
So what angles are equal, you said?
um, I'm sorry, BZG and CYG.
Yes, they are similar uh, because BG is the okay.
But
BG is not the bisector. I think. Oh, no, no, no. Never
but
mind.
wait. So you're saying you see why BZG and CYG are similar?
Yes.
How do you see that?
Hmm. It's a little complicated. Give me 5 minutes. I'll work it out.
Okay, it's all right. But let's just assume that these are similar for now. So then that would mean this ratio is true, right? Um, so that would
So
mean that
what we could do is we could reverse the thing by assuming by assuming the perpendicular bisector thing is correct and arrive at these result like the like the spiral part.
Yeah, so that's what I'm going to do. So I think I see how to do this. So first, let's just assume this ratio is true, right? So basically, that means that if this ratio is true, that means that I'm going to write this out. But triangles AYZ and so or I'll just say AZY is similar to RBC, right? And G corresponds to N because of this ratio. So G and N are corresponding parts of those triangles. And if that's true, that means angle ZAG equals angle BRN. And if that's true, I'm sorry, BRX. Wait, hold on just a sec. Oh no, it should be. I'm sorry. This should be BZ over CY. Yeah, I wrote. Yeah, that this comes from the similar triangles, and that's BX over CX. I know. 3, I 3, 4, 5, 4 is probably going crazy here, but but basically, I'm sorry. I'm just going to write out. So G and X are corresponding parts, and so ZAG equals BRX, and so I probably went a longer way than I had to, but hold on, I'm going to finish this before reading his comment. And so RX and S are collinear. Now let's see what he said. Oh, Timo said it. All right, Timo. If S is the intersection of ZY and BC, yeah. So yeah, this is Timo. Are you using this to prove that these triangles are similar? XG has to be the bisector of BGC. Yeah. So Timo is doing a step to prove that these triangles are similar. So what he's saying is, I'm sorry. So I only showed one of the angles was equal, but in the similarity. But we can also show there has to be a similar way to solve this, but I'm just going to stick with this for now. Yeah, I'm trying to let A intersect BC at a point. You know what? I'm literally just going to write YZ intersect BC. So my screen's freezing up. It sucks. But basically what Timo is saying is kind of complicated. This is maybe a little complicated, but so we have AX, BY, and CZ are concurrent. Right, Sheva. That's the Jargon point. So basically, so B, C, X, and so these 4 points are in harmonic conjugation. Whoops. And if that's true, then since angle XGZ is 90, then we have GX bisects BGC. And that's how we got that those triangles are similar. So Timo, I'm guessing this is what you were saying. Okay, so all this stuff, but yeah, so Rx and S are collinear, and then IG. But let's see. In his hint, he said. So okay, so Rx and AN meet on the circle, and then he said projective could possibly help. Okay. So we wanted to show Ri and N were collinear, right? This has gotten so complicated. Somehow that helps show that Ri and N are collinear. Or maybe we could just avoid Ri and N being collinear. I'm not sure. But that was what I was thinking. Let's see. The Sharky Devil point. Oh boy. Let's see what this Sharky Devil point is. This is someone else's blog. Interesting. Let's see. They don't have too many posts, but I guess this is an important one. I'm just gonna go back to this. Yeah, it doesn't look like these always concur. Well, maybe they do. No, yeah, these three don't always concur. Okay. R, I, and N. So yeah, I like this fact that Rx and AN meet on the circle, but I'm still not sure how we use that to get where we want. Well, if they were collinear, we could project through them onto the circle. So we would get H, S, R, and then we'd have to draw a parallel. I'm not sure if I like this, but let's see. Yeah, I don't really like that.
Is AB parallel to RS?
Is AB parallel to RS? I don't think so. I'll move the diagram around, but I don't think AB is parallel to RX, or no.
Okay, yeah.
But it's a good idea. Yeah, we want to show RI and N are collinear. I don't know. You guys want to move on to a different problem, or you want to see if I3435 has a solution? But wait, let's see if we could do something with spiral.
Yeah, if we could only go through the statement part of that deep shark property, then it would have been great. Like go through that deep shark property that he suggested.
Did you say that the Sharky Devil?
Yeah.
The Sharky Devil point. Let's see.
Because the figure and most of the properties overline here from that figure and this figure.
So it's saying take this intersection, then RP and I are collinear.
Yeah, we don't have to go through the proof, only the statement would make the work. And we could use that statement in our problem.
Okay. Yeah, I'm trying to see, because like in our problem we had something with like the midpoint of arc BAC, but I don't see any theorems here that have like a midpoint of arc BAC. But maybe there's like another way to solve the problem without it. Hold on one sec, I'll be right back again.
Why don't we locate the point of intersection of AZY and the circumcircle of ABC?
Yeah, it's this point right here, right? That's like the shark. Is that the Sharky Devil point? That's what I think it was, right?
Then try proving IGT collinear.
IG and T are collinear? Oh, IGT. Okay, so maybe all four of those points are collinear by the Sharky Devil property. Okay. Oh no, but it doesn't pass through the midpoint, but it passes through the other points. Yeah, it looks. Yeah, it's really hard to draw a diagram where it doesn't look like it lies on EZ, but I think that should do. So if that's like that Sharky Devil point, I'm just gonna read that or go back to it. Sharky Devil point. So yeah, RP and I are collinear is what it's saying. That's property one. Property two, it intersects it. Okay, this property two is clear. Uh, inversion. Maybe this is a good time to learn inversion. So Timo, what follows from inversion in center? Is it that does that solve the whole problem? Sorry. Sorry. That T, G, and I are collinear. The 9-point center goes on version. Okay, yeah, I think I see a proof. The 9-point circle of ZYX goes to the circumcircle of ABC. So is I the 9-point center of XYZ? I think it might be. No, I is just the circumcenter of XYZ. The 9-point center, I'm sorry. Yeah, so yeah, thanks for joining us, I3435. So yeah, whenever you have to leave, feel free. But yeah, thanks for your help with the problem. And yeah, I think you guys might understand the rest of the solution, but I'm just going to switch to another problem for now, if that's okay. Is that okay with all of you?
Yeah, we've got enough